Okay, on the last video, we kind of left off with this problem, and I noticed that I was really running out of time, so I quickly talked about these last two. We've already proved these very well, so I just want to make sure I just reiterate why these would not work. So real quickly, if we look at D being positive 6, meaning we would move on the x-axis to positive 6, and we know D is actually, as we were told earlier, directly below point A. And so we know that that would not be an option then. And then here again, it's the same thing. So we don't even really have to go any further looking at the rest of them. But again, D being positive 6, that would not put it directly under A. It's going to be over here, way out here and on the side with B. So that's why these would not work. All right, now let's move on to number 10. It says Rick decides that a triangular prism might use even less material for the surface area of the package. Find the surface area of this prism. So we know to find surface area, we're going to have to find the area of all faces, and then we're going to add them together. Since it's a triangular prism, we know that it has 5 faces, 1, 2, 3, 4, and then the back. So we need to make sure that we have 5 numbers in the end to add together since it has 5 faces. So depending visually how a 3-dimensional figure looks to you will depend on what you call things. So I am going to call this side here as my right side and this side as the left side, this triangle being the top and the bottom, of course, triangle being the bottom, and then we have the back rectangle. So starting with the right side, we can see that that's a rectangle, so we know the area formula for a rectangle is length times width. We can see that those dimensions are going to be 8 and 10. Okay, so we have 8 times 10, which would give us 80 inches squared for the right side. Okay, we are going to now look at the left side. And the left side would be this piece here. And as we can see, the left side, this is 10. This is also going to be 10. If you want to go ahead and start writing dimensions so it helps later, we know this is 10, this is 10. This would be 10 as well. Okay, and so we can see that this side here is going to be a 10 by 6. It is another rectangle, so length times width. So we have 10 by 6. And so that's going to give us an area of 60 inches squared. All right, now if we look at this a little closer, I'm going to call that the top, and directly below it would be the bottom. So as we can see, those are going to be the same triangle. So I'm just going to say 2, because we're looking at 2 that are the same, which is going to be the top and the bottom. Now, because these are both triangles, we know the triangle that we have base times height divided by 2. And so therefore, we're going to go take a look at the triangle. So we can see from the bottom that it's 8 and 6. Also, if this is 8, this is going to be 8. If this is 6, this is going to be 6. You can see the perpendicular base and height. So we have 8 by 6 divided by 2. And 8 times 6 is 48 divided by 2, which is 24. However, that's for one of the triangles. So we're going to do 24 times 2 of them, and that would actually give us 48. So the area of the 2 triangles would be 48 inches squared. Okay, then we have the back. So when we look at the back, we can see that we have a 10 by 10 going on there. And that is another, well, with it being a 10 by 10, obviously that would be a square. So we can say length times width. And that's going to be 10 times 10. That would give us 100 inches squared. Okay, so that's area of each side. We want surface area, so we want to add them all up to get the entire thing. So that means we want 80 inches squared, 60 inches squared, 48 inches squared, and 100 inches squared. Okay, so we've got our 100, we've got our 48, we've got our 60, and we've got our 80. Okay, and you might want to use your calculators. Okay, so we have 148, 60, and 80. And that is going to give us 288. Now, we have found surface area. That is 288 inches squared as our final answer. And so we would choose A in this case. All right, let's move on to number 11. The perimeter of triangle QRS is blank centimeters. So we want perimeter. The area of triangle QRS is blank square centimeters. All right, in order for us to find the perimeter, we're going to need to know the measurement of each side length of our triangle. We can see that this side length here is 10 centimeters. And then that is the only side length they give us. So if we start with trying to figure out this side length, we're going to write down point S is at 5/8. So there are your ordered pair, your coordinates there. And then R is going to be 5/2. Okay, so what we're looking at here are 2 points that are in the same quadrant. So if the ordered pairs are in the same quadrant and your X values for both ordered pairs are the same, then you are going to subtract the absolute value of the Y coordinates. Okay, so these are the two that we want to focus on, absolute value. So I want the absolute value of 8. Remember, we're going to subtract the absolute value. So 2 is our other one. Okay, so the absolute value of 8 is 8 minus the absolute value of 2, which is 2, would equal 6 centimeters. So we know that this side length is going to be 6 centimeters. Okay, from there, we're going to look at the next one. They give us point Q, which is at -3, +2, and then R is going to be 5/2. Okay, what we want to notice here is these 2 points are in 2 different quadrants. So if the ordered pairs are in different quadrants, you're actually going to add, instead of subtract, you will add the absolute values. So if the Y coordinates are the same, you're actually going to add the absolute value of the X coordinates, of your X values. Okay, so what we want is the absolute value of -3, and we want to add the absolute value of 5. Absolute value of -3 is 3, plus the absolute value of 5 is 5, and 3 plus 5 would be 8 centimeters. So we know that this side is 8 centimeters. Now that we have our measurements, we can easily find perimeter by adding up the sides. So we have a side of 10 centimeters, plus a side of 6 centimeters, plus a side of 8 centimeters. And you can quickly add that up or use your calculator, but that's going to give you 24 centimeters. And since we're finding perimeter is not squared. That would be area, volume is cubed. So be careful not to, put your any kind of units on there other than just centimeters. All right, then we're going to move to the area of a triangle. We know area of a triangle is base times height divided by 2. So if we look at our triangle, we know we have a base of 8 and our height runs perpendicular, so that's going to be 6. 8 times 6 divided by 2. 8 times 6 is 48 divided by 2. And 48 divided by 2 is 24 centimeters squared. So the area of the triangle QRS is 24 square centimeters. All right, let's move on to number 12. Number 12 is asking what the volume is. So we know with volume, we know it's to the third power. Sometimes what I like to do is go ahead and put the unit once you realize it, because you know your answer is going to be cubed, and in that way you wouldn't forget it in the end. All right, we know volume is going to be length times width times height, or base times height, and we know the base includes length and width. Okay, so we know we have 4 by 4 by 6. And 4 times 4 is 16 times 6. So if you want to work that out to the side or just put in 16 times 6, you get 96. So your volume is going to equal 96 inches cubed because volume is cubed. 96 inches cubed. Okay, let's move on to the next one. The next one says a box needs to be painted. How many square inches need to be painted to cover the entire surface of the box? So we need to find surface area. All right, so let's just go ahead and get some measurements. We know if this is 12 inches, then this is going to be 12 inches. We got 6, which means that's 6 inches, that's 6 inches. The 12 will continue here. We've got 15, this would be 15, this would be 15. And so hopefully that's going to get us all our measurements. All right, I'm going to start with the top and the bottom. So that's going to be 2. The top and the bottom are going to be the same. So if we find 1, we can just multiply by 2. All right, since we're dealing with a rectangle, we want length times width. The top we can see is 15 by 12. So we have 15 by 12. That's going to give us an area of 180. However, we have 180 times 2 to include the bottom, which is going to give us 360. So I have an area that is 360 inches squared for the top and the bottom. Now, the front and the back are going to be the same. So 2 of those, front and back. Okay, and we know again, dealing with those, that those are rectangles, so we're going to do length times width. And as we can see, the front is a 15 by 6, so the back would also be 15 by 6. Okay, 15 times 6 is 90, but again, we have 2 of them, so we want 90 times 2, which is going to equal 180. So area is going to equal 180 inches squared. All right, now we have the right side and the left side. So those 2 are going to be the same thing. I'm just going to call them sides. It includes the right side and the left side. Again, we're dealing with rectangles, so area equals length times width. We're looking at a 12 by 6. So 12 times 6. So area is going to equal 72. However, we have 2 of those, so we want 72 times 2, which is 144. Area is going to equal 144 inches squared. Okay, so we need this area, and this area. All right, so I'm going to come over here. We've got 360, we've got 180, and we've got 144. So let's add those up. We're out of time again, so add those up and move to the next video.